Welcome to All Computery Tutorials. Today I'd like to talk about a concept known as recursion, and it's a really interesting concept in computer science. It deals with a method that can call itself. And with that teaser, I figured I would start off with a really cool picture because that's one of the beautiful examples of what you can create with recursion. We're not going to get there today. We're going to stay a little bit more basic than that. But I do want to talk about some of how it works and give an example of what recursion is. So first off, here's the mathematical definition of the Fibonacci sequence. The idea that we're working with here is that if you want the first number in the Fibonacci sequence, that is always 0. If you want the second number, that is always 1. And any number after that is the sum of the previous two. So let's take a look. We've got an example here. As you can see, our first number is 0. Our second number is 1. Our third number is 1 because 0 plus 1 equals 1. Our fourth number is 2 because 1 plus 1 equals 2. Next number, I don't even know what sequence we're at, but next number is 3 because 1 plus 2 is 3, and next number is 5 because 2 plus 3 is 5. Now that you're all bored to death, that's the way that this goes. And let's say you've got an elementary school teacher who wants you to write out the 50th number in the Fibonacci sequence, and she's really mean, so she took away your smartphone, you can't Google it. Who has time to write out 50 numbers on a piece of paper, and who has that kind of energy in their hand? It's really difficult. So, fortunately, crunching numbers in busy work is something that computers are extremely good at. So this is a very basic program that solves the Fibonacci sequence. Right here we have a recursive function. As you can see, it's a method that calls itself in its return statement. So when we get into the method, first we check, do we already know what the answer is? We ask, are we looking for the very first number in the Fibonacci sequence, or are we looking for the second number? If we're looking for the first or second number, the answer is 0 or 1 respectively, and we can just return that. We don't have to search for it at all. If it's anything bigger than that, we're going to need our function to go ahead and search for it. So just like that mathematical definition, we take the Fibonacci sequence for the number 1 less than the number we're currently working with, and the Fibonacci sequence for the number 2 less than the number we're currently working with. And then we call our method to find the Fibonacci sequence, and we're done. It's honestly that simple. Recursion is often not a lot of code, even though the dynamics of what's happening is really thoroughly complicated. So let's go ahead and test that out. We're going to ask for the first number in the Fibonacci sequence. That gives us 0. And then we're going to ask for the second number, which is the first, or the index of 0, or 1, excuse me, and that gives us 1. Let's go ahead and give it 10, just to see if it can do that correctly. When we run that on 10, it gives us 55, which is the 10th number in the sequence. So why should you care about this? The truth is that recursion is a very complicated topic. It's something that you could write a PhD thesis on, you could write a master's thesis on this, and we are looking at what is probably the most basic example. And I'm glossing over this. I'm not even going into some of the details of how the call stack works and the deeper levels of recursion. But my goal here is really just to get you interested. If you find yourself confused and frustrated by this, I do apologize. Please let me know. I'll try and put up a better explanation. But if you find yourself interested by this and maybe typing out the example that I've got here to see if it works and messing around with it or wondering about some of the finer details of how recursion actually functions, then I would strongly encourage you to either make computer science your major in college or to continue looking into it at least. It's kind of the tip of the iceberg of a very fascinating field and a very fascinating topic called recursion. And if you find this interesting to yourself, you might have the programming bug, which is a label I've given to people who sort of get addicted to programming and just really enjoy it, and their brains work that way, and it's fun to them. As always, this has been a screencast version of a tutorial that I've got out on my blog. It's known as allcomputery.blogspot.com. Go ahead and take a look. There's lots of other good stuff. Some of it might help you, some of it might not, but hopefully it'll make you a better programmer. Thanks for watching.